Today we're doing section 2.7 and we're going to be solving polynomial inequalities. So the general procedure for these, your first step is always to get your polynomial to the point where it's either greater than 0 or less than 0. So essentially, if there's not a 0 there, you need to get it to be 0 by getting all your terms on one side. Your next step is to solve for x and plot those values on the number line. After you plot your values on a number line, it's going to break your number line up into sections. So your third step is to test values from each region. And the final step is you would shade in regions that work, or regions that are true statements. So before, when we were finding like the x-intercepts when we were solving, we would get, so for example, if it's a third power, you get 3 specific answers. Now we're going to get a whole abundance of answers because you're going to get an inequality as an answer. So like, for example, you'll get x is greater than 1, which means everything larger than 1 would work in the problem. So for example, here's our first one, and it says 2x squared plus 2x is greater than 15. So again, in that process, we said we have to have it a 0, so I need to get all my terms on one side. So now I'm dealing with a 2x squared plus x minus 15 is greater than 0. And this greater than 0, we're just going to treat it as if it's an equal to 0, so you don't really worry about that, and it's just old school factoring here. Those of you who prefer quadratic formula, you could use quadratic formula here. So I'm trying to find what multiplies to be negative 30 and adds to be a positive 1. So that'll be a 6 and a negative 5. So those of you who do the box method, that's your combination for the box method. Those of you who factor with the grouping method, you would do the grouping method here. And again, it doesn't matter the order between the 6 and the negative 5. So I group the first 2, group the second 2. I take out a 2x. I'm left with x plus 3. I take out a negative 5, and I'm left with an x plus 3. So we get 2x minus 5 and an x plus 3. And again, those of you who do the box, you should have gotten the same result. So the two answers that we get are 5/2 and a negative 3. So these are our two values that need to go on the number line. So I'm going to switch the screen to do the number line part of this problem. Okay, so here's a 0. 1, 2, 3. Here's our 5/2, and we have a negative 3. So notice I'm going to be using open dots here. The reason we use open dots is this is where the function is equal to 0. Notice that statement said 2x squared plus x minus 15 is greater than 0. So if I were to plug in negative 3, I would get 0, and 0 is not greater than 0. So that's why we're using open dots for both of these statements. So now we need to test our regions. So a value that I could test in the left-hand region is negative 4. A value in the middle region I would say is 0. And the value to the right-hand side I would test is a 3. So by putting those 2 dots on our graph, I broke my section up into 3 pieces. So I need to test all 3 regions. So I'm going to determine which is a true statement. So I'm going to plug negative 4 in everywhere I see x. And I'm trying to determine if this is true or not. So I know negative 4 squared is 16 times 2 is 32. And then I'll have a minus 19. And really, at this point, I don't really even need to go any further. I don't actually need to subtract 32 minus 19 because I can see that I'm going to get a positive number, and I know a positive number is greater than 0. So I know the statement's true. So I'm going to shade up until negative 3. I can't continue to shade because I didn't test that middle region, so I don't know if anything from that region is going to give me a true statement. So now I need to test 0. So I'll do 2 times 0 squared plus 0 minus 15. So I'll get 0 plus 0 minus 15. And again, at this point, you really shouldn't have to do much more work. You should be able to look at that and say, well, negative 15 is not greater than 0. So this statement is not true. So I'm not going to be shading in between those two dots. If 0 doesn't work, that means 1, negative 2. None of those values will work. So the last region I need to test is the region to the right-hand side, and that's going to be the positive 3. So a 3 squared is 9, times 2 is 18. 3 minus 15 is a negative 12. And again, at this point, 18 minus 12 is 6, which I know is greater than 0, so I know this statement is true. So I'm going to shade over here. So the last thing that I ask is that once you have this number line, we interpret our answer in interval notation. So notice I shaded everywhere to the left of negative 3, so that means I'm coming from negative infinity to negative 3. Notice I use a parenthesis because it's an open dot. And then my answers pick up on the other side at 5/2, and they're going to go to infinity. So anywhere between these two areas, if I use smaller than negative 3 or greater than 5/2, I would get a solution to this problem. If I use anything between negative 3 and 5/2, I would get a false statement. So let's try one more. So what's going to be consistent in every problem is the number line part. The way we obtain the answers is different for every single problem. So again, I need to get this equal to 0. So I'm going to subtract the 4x over and the 4 to both sides. So I get x cubed plus x squared minus 4x minus 4 is less than or equal to 0. And when I look at a problem that has 4 terms like this, I just go right into the grouping. Or my boxers, you have 4 terms, so you go right into putting all 4 terms in a box. So I can take out an x squared here, and I'm left with x plus 1. I can take out a negative 4, and I'm left with an x plus 1. So this will factor down to be x squared minus 4 and an x plus 1. And now I set both of these equal to 0 and solve. So x squared minus 4 equals 0. I'd add the 4 over, and I take the square root. So I get the answers of plus or minus 2. And here I'll get the answer of a negative 1. So notice I now have 3 values to go on my number line, which means I'll have 4 regions to test. So I'm going to switch my screen. So here's my 0. I got a positive 2, negative 1, and a negative 2. So this time on my number line, that problem was x cubed plus x squared is less than or equal to 4x plus 4. So all of those answers that we got of zeros are going to be closed dots because of that equal to in the problem, and a positive 2. So now I determine my values that I'm testing. So we're going to test, so this is a negative 2. We're going to test a negative 3, a negative 3/2, 0, and a positive 3. Okay? So we have lots of areas, lots of different values to test. Also, you have various different equations that you could plug into. I recommend going back into the original just in case you made a mistake with your solving. It's better to go to the original. So here I have negative 3 cubed plus a negative 3 squared, and I'm trying to determine if this is less than or equal 4 times negative 3 plus a 4. So negative 3 cubed is a negative 27 plus 9. And over here I have negative 12 plus 4. So this will be negative 18 less than or equal to negative 8. So I know that that is a true statement. So I'm definitely going to be shading up until the negative 2. So now I need to test that negative 3/2. So I have a negative 3/2 cubed plus a negative 3/2 squared less than or equal to 4 times this negative 3/2 plus 4. And please be my guest if you prefer using fraction or decimals. You may use decimals. I'm just going to keep it as a fraction. So here I'll have a negative 27 over 8. Over here I'll have a 9 over 4. On the right hand side I'll have a negative 12 over 2. So we would want to fix this up a little bit. This 9 over 4, I'm going to multiply by 2 over 2 and make that be an 18 over 2, so I have common denominators. So negative 27 plus 18 is going to be negative 9 over 2. I know negative 12 over 2 is a 6, negative 6, and negative 6 plus 4 is negative 2. And negative 9 over 2 is negative 4.5. So that's also a true statement. So I'm going to continue with the shading up until negative 1. So here I have to pause, and I definitely need to test this region of 0. And actually looking back, I made a mistake here. This should be 18 over 8. So this would be negative 9 over 8, and this would be negative 1 point something. So this is actually going to be a false statement, not true. So I should not be shading there. So my apologies on that. Alright, so now we're going to test our 0. So I can squeeze the 0 here. So I have 0 cubed plus 0 squared less than or equal to 4 times 0 plus 4. So we get 0 is less than or equal to 4, which is true. So I'm definitely going to be shading between negative 1 and negative 1 and positive 2. So the last region we need to test is a 3. I'm going to switch the screens. So I have 3 cubed plus 3 squared is less than or equal to 4 times 3 plus 4. So we'll get 27 plus 9 is less than or equal to 12 plus 4. And again, right off the bat, you should be able to see that the left-hand side is not going to be less than the right-hand side. So this is a false statement. Sorry. So I'm not going to be shading over there. So the last thing we need to do is just interpret this answer. So we would use our interval notation for our final answer. And I would say negative infinity to negative 2. Bracket on the negative 2. Union negative 1 to positive 2 with a bracket. So this is our final answer. So again, this tends to be a little bit difficult of a lesson, so we're definitely going to do a lot of practice of this tomorrow.